This video is a review of the Socrative on conditional probability. The first few questions were based off this Venn diagram. And the first question asks the probability of f. Well, that's just the cardinal number of f over the cardinal number of u. So f has 37 in total, and the whole Venn diagram has 50. So you can write your answer as 37 over 50, or 0.74. Question 2 is an easy one again. Probability of s is 24 because the total of the S set is 24 over 50 because that's the total of the entire universal set. This can also be written as 0.48. Question 3 is to find the probability of F intersection S. Of course, the intersection is this region here in the centre. So it's going to be 14 over 50 or 0.28. Question 4 is to find the probability of F union S. Well, that's the entire central section here, the F and S regions all together. And that's 47 over 50, or 0.94. Question 5 asked you, what is the probability that somebody plays a sport, given that they, apologies, I read that the wrong way around. Let me just fix that. The probability that they speak a foreign language, given that they play a sport. It's important that the given term or event goes in at the end there. So I've got the formula up the top here, just the general formula, probability of A given B equals probability of A intersection B over probability of B. So in this case, that's the probability of F intersection S over the probability of S, which is 14 over 50 over 24 over 50. If you write it in this way, of course, you could write it as 0.28 over 0.48 as well if you liked. But if you write it as a fraction, just note that since the denominators are the same, you can cancel those out. And that leaves you with just 14 over 24, which you can cancel down to 7 over 12, or 0.583. Question 6 asks us to find the probability they speak a foreign language, given that they don't play a sport. So we want to find the region of our diagram where F intersects with S complement. So now S complement is everything outside of S. So if I cover over S, what part of the remaining visible regions intersect with F? So it's just this 23 over here. So that's 23 over 50. And the probability of S complement is just everything outside of S. So that's 26 over 50. So like the last time there, because both denominators are the same, I can cancel them out, and my answer is 23 over 26, or 0.885. And just watch out there with your rounding off and questions like that. The next set of questions were based off this diagram. And the first of the questions relating to this was to do with shapes. I had to select a shape, not replace it, and then select a second shape. And I gave you a hint in the question to draw a tree diagram. So I've set up the skeleton for my tree diagram. And the first shape that I choose can be a circle or a triangle. And the second shape that I choose can be a circle or a triangle. And I'm just going to fill in my probabilities now. So on my first selection, I've got 9 and 17 as my probability of choosing a circle, and 8 and 17 for a triangle. But just watch out, once that shape comes out, it's not replaced, so that'll affect the subsequent probabilities in the second column. This was commonly overlooked when answering this question, so just watch out for it in future. My outcomes are listed in the outcomes column, and my probabilities are calculated, and I've given the simplified versions in the probability column. Notice that I've left them as fractions, because if I was to write these as decimals, I'd have to round off. So it's better in that case just to stick with a fraction. Okay. So answering my question then for question 7, I want to find the probability that both are circles. So probability of CC, which is 9 over 34. Question 8 is similar in that I'm selecting a shape and not replacing it. But this time I'm focusing on the colour of the shape that I'm selecting, not the shape itself. So this will require me to draw a separate tree diagram. So I've set up my tree diagrams columns, as you can see. And since I'm focusing on colour here and it's about it being blue or not, I'm going to say blue and not blue. So B and NB. And I'm going to fill in my probabilities. So I filled those in there, as you can see. And again, it's the same idea as before. Don't forget that the object is not, the shape is not being replaced in the group once it's been selected. So that does affect our probabilities in the second column here. I've filled in my outcomes column, and I've filled in my probabilities there at the end, and then I go back to the question which asked me to find the probability that both shapes are blue. So I just go back and select the relevant one from the tree diagram, and it's 3/136. Question 9 asks us to find the probability that both shapes are the same, given that the first shape is a circle. So this is our conditional probability formula then. So don't forget, it's the probability of A intersection B over probability of B. So in this case, it's the probability that both shapes are the same and the first shape is a circle over the probability that the first is a circle. So now to figure out these probabilities, I can just go back and revisit my first tree diagram again. So I can see that the probability that both are the same and the first is a circle is this option here. And the probability that the first one is a circle would require me to add both of these options here. So I'm going to write that as 9/34 over 18/34. And again, I can do a little bit of cancelling there to get 9/18, which is obviously a half. So our last question then is to find the probability that both shapes are different, given that one is a triangle. So again, we'll try and rephrase this using our formula for conditional probability. So we'll write that as the probability that they're different and one is a triangle over the probability one is a triangle. So we'll go back now again and revisit our first tree diagram to decide what our values should be. So which options do I have different shapes where one is a triangle? Well, this option and this option. So they'll be going on the top of my fraction in my solution. And then I want to know in which options is one of the outcomes a triangle. So there, and well, definitely one of those outcomes is a triangle, because in fact both of them are. So I end up with 18/34 over 25/34. A little bit of cancelling going on there again. And my answer is 18/25, or 0.72 if you like. Just a word on the phrasing of that question 10 and the value that we put here in the denominator. The question says that we want to find the probability both are different, given that one is a triangle. Notice it doesn't say that exactly one is a triangle. So in the probability we're putting on the bottom, as long as there's a triangle present in either of the shapes that are chosen, we're good to include that. And that's the reason where it was okay for me to include TT as part of my denominator. If they had said exactly one is a triangle, then I wouldn't have included that.